All right, so we spoke about our simple lighting system in our last video, and that's our light board, our DMX controller, and a signal cable, which is known as a DMX cable. It goes into our dimmer, which then regulates the electricity that goes out to our light fixture, right? So DMX stands for digital multiplex. It's known as DMX 512. It is by way and far the most common communication protocol that we have for stage lighting now. DMX cable has 5 pins and it's in an XLR connector shell, right? So DMX 512 has 5 pins, XLR. The 512 stands for the fact that it can carry 512 discrete signals on this one piece of wire. It is a digital communication protocol, and it can run a really, really long way, 1,000 meters. That's more than 3,000 feet, 3,000 yards, so 9,000 feet. So we can run around a football stadium with DMX if we need to, and some people do, right? So this is our simple DMX system, right, with our DMX controller and dimmer that then outputs to our light. As we move up in complexity, let's go ahead and think about our dimmer as not just one dimmer, but actually has 4 dimmers. Channel 1, dimmer 2, dimmer 3, and dimmer 4, right? And we want those individual dimmer outputs to correspond to slider 1, 2, 3, and 4. So when I slide up number 1, we're going to send DMX signal into our dimmer, which is going to tell dimmer number 1 to turn on, which is going to turn on our first light. Conversely, or additionally, when we slide up number 2, it's going to send signal to our second light, and number 3 to our third light, and 4 to our fourth light. This dimmer then needs a starting address, right? It needs to know where to begin listening to the signal that we're going to be sending to it, right? So the easiest way to think about that is starting address is going to be for the beginning of where this dimmer pack is. If I set its starting address to 1, it will presume that dimmer number 2 is going to listen to the second address. Dimmer number 3 will listen to the third address, and dimmer number 4 will listen to the fourth address. It is very uncommon that you can alter that. The starting address will assume all additional addresses within a device. So let's go ahead and step up a little bit. So DMX 512. The cool thing about DMX 512 is it can be daisy chained, right? So we can run into one device and come out of it and go into the next device and the next device and the next device and the next device. And each one of these devices is going to need a starting address. If we were to look at our diagram over here to the right, we have our first dimmer pack with a starting address of 1. So dimmer number 1 on this dimmer pack corresponds to DMX address 1, 2 to 2, 3 to 3, 4 to 4, and so on. Our second DMX device is going to want a starting address of 5 so that its first dimmer corresponds to 5, and its second dimmer would correspond to 6, its third dimmer to 7, and its fourth dimmer to 8. And that way we have individual control of all of these. If this start address were set to 1, both of these lights would come on when we brought up our first fader. And what we want to have is individual control. You can think of the DMX as sort of like the way your mailboxes work. The mailman comes by and drops off information in their first device for the 4 people that live there, or the 4 dimmers that live there. 1, 2, 3, and 4. And then the mailman comes down and drops off information for 5, 6, 7, and 8. And then 9, 10, 11, and 12. And they just keep going down the street dropping off information at the specific mailboxes that are along their route, right? Now DMX is a little more sophisticated than the post office, right? Our first dimmer, right? We can look at our first dimmer is now addressed to 1. That's going to be 1, 2, 3, and 4. Light 1, 2, 3, and 4. Our second will be addressed to 5. So this first dimmer would correspond to 5. Our second dimmer to 6. Our third dimmer to 7. Our fourth dimmer in this pack to 8. And our next available address is address 9. So in our third dimmer pack, we're going to set this address to 9, right? So our first one then is 9. Our next one would be 10. The next one 11. And the last one would be 12, right? Each device only needs its starting address, and the following addresses are presumed. Now, DMX doesn't have to be, we don't have to use all 512 addresses. We could set the starting address of our first dimmer pack to be 1, which would make it 1, 2, 3, and 4. And we can set our next address as 11. So our first dimmer then would correspond to 11, 12, 13, and 14. Our next dimmer could be 21. So that would be 21, 22, 23, and then 24, right? This is known as hotel patching. And sometimes it's easier to organize our information rather than trying to remember what all starts with what. I can just remember that my first address is 1, my next address is 11, my next one is 21, and then 31, and so on. And it just can make life a little bit simpler because this is now 21, 22, 23, and 24 for this dimmer pack, right? So that's known as hotel patching. Let's look. Addresses don't need to be sequential. Unlike the mailbox that's just running down in sequential numbers, DMX can listen anywhere along the path for the information that is relevant to that starting address. So our first dimmer can be addressed to 1, 1, 2, 3, 4. Our next dimmer could be 101, which would be 101, 102, 103, and 104. And then our last dimmer pack at 21, 21, 22, 23, and 24. We only need the starting address. It doesn't need to be sequential, and we don't need to use every address on the path. We can assign whatever we want in whatever order we want along our DMX path. And we'll be back and talk more about DMX.